Welcome back to Think Thrice. Today we're going to be solving another fun integral. So this integral was recommended by a viewer who saw the 1 over x cubed plus 1 integral and said, hey, can we do the same thing for 1 over x to the fourth plus 1? And the answer is we can't do the exact same thing, but we can do something kind of similar. So if you'd like to give this integral a try, go ahead and pause the video and take a few minutes. Otherwise, let's go ahead and jump in. So in the first video, for 1 over x cubed plus 1, what we had done is we had factored it. In this case, I noticed that x to the fourth has only imaginary, x to the fourth plus 1 will have only imaginary roots. So I won't be able to factor that all the way down, but what I can do is try to reduce the degree under the polynomial. So let's go ahead and note that x to the fourth plus 1 is the same as x to the fourth plus 2x squared plus 1 minus 2x squared. Okay, all I did was add and subtract 2x squared, which is the same as x squared plus 1 squared minus 2x squared. So what I notice here is that I have a square minus another square. So what I can do is I can factor that as my first number, which is x squared plus 1, plus the square root of my second part, which is root 2x, times x squared plus 1 minus square root of 2x. Okay, and remember that's because a squared plus b squared is equal to a plus b times a minus b. Okay. So what I've just done is I've gotten to a point where now I can rewrite my integral. Let's rewrite my integral as the integral of 1 over x to the fourth plus 1 is equal to the integral of 1 over x squared plus, So what I've just done is I've made it so that I can split this up in a partial fraction decomposition. So I'm going to write this now as 1 over x squared plus 1 plus square root of 2x times x squared plus 1 minus square root of 2x. So let's go ahead and do a partial fraction decomposition here. So if I want to break this up into 1 over x to the fourth plus 1 is equal to ax plus b over x squared plus root 2x plus 1 plus cx plus d over x squared minus root 2x plus 1. When I multiply that guy out, I'm going to get 1 on the left is equal to ax squared minus root 2 ax cubed, ax squared plus ax plus bx squared minus root 2 bx plus b plus cx cubed plus root 2 cx squared plus cx plus dx squared minus root 2, plus root 2 dx plus d. So first, let's take a look at our x cubed terms. For our x cubed terms, we have 0 on the left side of equal. So this is x cubed. We have 0 is equal to negative 2 is equal to a. So there's 0 over here. And on the right side, we have a, and we have c. So a plus c, which tells us that a is equal to negative c. Next, let's look at the 1 terms. So on the left, I have 1, and on the right, I have b plus d. Next, let's take a look at our x squared terms. So for our x squared terms, on the left we have 0 again, and on the right we have negative root 2 a plus b plus root 2c plus d. And that's all equal to, or sorry, that's already equal to 0. Okay, so what I notice is that on this side I have b plus d, which is equal to 1. And I also have this a term and this c term, and I know a is equal to negative c. So I can rewrite this whole equation as negative 1 is equal to c times 2 root 2. So that c is equal to negative 1 over 2 root 2. And because of that, I know that a is equal to positive 1 over 2 root 2. Now looking at my last equation, let's look at x. So my x terms. On the left I have 0 again. And on the right I have a minus root 2b plus c plus root 2d. I already know that a and c are opposite signs, so these two guys are going to cancel. And I'm going to be left with b is equal to d. But since I already know that b plus d is 1, that means b and d are both 1/2. Okay, so what I've just determined is my partial fraction decomposition. So now I can rewrite my whole integral. So remember, I started with 1 over x to the 4th plus 1 dx. And this is going to be equal to a, 1 over 2 root 2. So I'm going to bring that 2 root 2 to the denominator. And that 1 is times x plus 1/2. But I already brought out the 2 root 2. So that's going to be plus square root of 2, because square root of 2 over 2 root 2 is 1/2. And that's all multiplied by x squared plus root 2x plus 1. And then I'm going to have the same thing on the, I'm going to have a minus. And then I'm going to have negative 1 over root 2 root 2. So I'm going to bring that 2 root 2 for c into the denominator. And that's x. And then this time it's minus because I pulled out the negative sign. So that's going to be minus root 2 over x squared minus root 2x plus 1. And that whole thing is going to be dx. And then because I'm taking the sum of two things, I can rewrite that integral as the sum of two integrals. Okay, so now what I've done is now I have two integrals with a second degree term in the denominator instead of a fourth degree term. So let's start off by looking at this first integral. So I'm going to name this integral, integral 1, this integral on the left. So looking at this integral on the left, it would be really, really nice if I could take out that denominator, so u equals x squared plus root 2x plus 1, and use that with something in the top because I have a first degree term in the top. So the derivative of that's going to be 2x plus root 2 dx, which is almost what I have at the top. So let's go ahead and rewrite that integral. So I'm going to write it as the integral. I'm going to pull out a 1 over 2 root 2. And then what I'm going to do is I'm going to pull out a 1/2, and I'm going to multiply the top by 2. So I'm going to get 2x plus 2 root 2, but I'm going to write it as 2x plus square root of 2 plus the square root of 2. Okay, so 2x plus 2 root 2, I'm just separating it. So this guy is going to be divided by x squared plus root 2x plus 1. And I'm going to have the same denominator over here. And once again, since I have the sum of two things, I can split that integral and write it as 2. But remember that both of these are multiplied by 1/2 times 1 over 2 root 2. Okay, so now because of the way I formed this, I know that this left integral, because I formed it using the u substitution, is just going to be 1 over 4 root 2 times the natural log of x squared plus square root of 2x plus 1. Okay, that's just how I built that thing. So now I just have to worry about this right integral. So this right integral is 1 over 4 root 2 times the integral of root 2. And since I have a squared term and I just have a constant in the top, I'm thinking right here that trig sub is probably the way to go. So let's, instead of that x squared plus root 2x plus 1, let's complete the square down there and write that as x plus root 2 over 2 squared. So that would give me x squared plus square root of 2x plus 1/2. So I'm going to have to add one more 1/2 over here. Okay. So let's go ahead and pull out a few things. So first off, I noticed that the root 2's cancel. I would rather have it in the standard format where I have 1 over something squared plus 1. So let's go ahead and rearrange this a little bit. And let's multiply the top and bottom by the number 2. And that's going to give me 2 over 4 times the integral of 1 over 2x plus root 2 over 2 squared plus 1 dx. So now this is looking pretty good. So now I can see that if I make, so I'm going to block off this. So this is something I need in my final answer. So if I make tangent of theta equal to root 2 x plus root 2 over 2, should be equal to root 2x plus 1. Then I plug it in and I'll be able to get that directly. So what I'm going to end up here is going to be, this whole thing is going to be 1/2. And then I'm going to have arctangent of square root of 2x plus 1. And since there's a square root of 2 in there, I'm going to then have to divide that by the square root of 2. Okay, so since there's that root 2 here, I'm going to have to divide it when I integrate using the chain rule. Okay, so I have another puzzle piece that's part of my final solution. Looking pretty good. So now we just have this last part. So let's take a look now at this second portion, which I'm going to call integral number 2. And let's rewrite integral number 2 down here. So for integral number 2, I have negative integral of x minus root 2 over 2 root 2 times x squared minus root 2x plus 1 dx. So let's do the same thing we did above. I'll go through it a little bit more quickly. So if we make u equal to x squared minus root 2x plus 1, then du is going to be 2x minus root 2 dx. So when we do that substitution, we're then going to get negative 1 over root 2, 2 root 2. Multiply that by 1/2 again. And then on the inside, we're going to get the integral of 2x minus root 2 minus root 2 again over x squared minus root 2x plus 1. I'm going to rewrite this a little bit. So we're going to get minus root 2 over x squared minus root 2x plus 1 dx. And we can split these up again. And remember that both of these are being multiplied by that negative 1 over 2 root 2 times 1/2. So looking at this again, so this first part of my integral is just going to become negative 1 over 4 root 2 times the natural log of x squared minus root 2x plus 1. And my second integral is negative times negative, so I'm going to have 1 over 4 root 2 times root 2, so that's going to cancel, times the integral of 1 over x squared minus root 2x plus 1 dx. So let's go ahead and rewrite this. So once again, we're going to have 1 over 4 times the integral of 1 over x minus root 2 over 2 squared. This time plus 1/2 again. Multiply the top and bottom by 2. And I'm going to get 1/2 the integral of 1 over 2x minus root 2 over 2 squared plus 1 dx. This time we're going to make tangent of theta equal to root 2 times x minus root 2 over 2, which is the same as root 2x minus 1. So this whole thing is going to end up being 1 over 2 root 2 times the integral, sorry, not times the integral, arctan of x minus, square root of 2x minus 1. All right. And now all we need to do is put all of our 4 pieces together, and our integral, which we've just solved, will be the integral of 1 over x to the 4th plus 1 dx is going to be 1 over 4 square root of 2 times the natural log of x squared plus root 2x plus 1 plus 1 over 2 root 2 arctan of root 2x plus 1 minus 1 over 4 root 2 natural log of x squared plus root 2x plus 1 plus 1 over 2 root 2 arctan of root 2x minus 1. And that whole thing is going to be our solution. So it ends up a little bit messy, but when we actually work all that out, that's going to equal exactly what we want it to. And that's it. So thank you for coming along on that journey with me. If you have your own integral that you'd like me to work through and solve, then feel free to submit it. If you enjoyed this content, please like and subscribe. And as you're working through problems, always remember to think thrice.